Now, in this question here, which postulate or theorem, if any, could you use to prove that the two triangles are congruent? If not enough information is given, write not enough information. Now, look at the first one. Let's name it with A, B, C, and D. Now, from here, as we see, AB is congruent with CB, and an angle ABD is congruent with an angle CBD, and BD is congruent, the line segment BD is congruent to the line segment BD because of the reflexive property of congruence. Now, after that, look at here. Here I have AB, so I have a line segment, which is S, angle S. So which postulate you will use here? You will use SAS to prove that these two triangles are congruent. Now look at number 4. In number 4 here, we have sides let's name them also with A, B, C, D. So AD is congruent with AD with CB, and angle D is congruent with an angle B, and AC is a side that is congruent with AC also because of the reflexive property. Here it's given, and here it's given. Now, here we have side, angle, and side. Let's see here. Side, angle, and another side. We have only angle, side. That's mean I have two angles and one side that's are out of them. Here I have only one angle with two sides, so I can use SAS because I have two sides. But the angle here, it's not included. So which theorem or postulate would I use? SAS cannot work. Here I have side, angle, or I can say side, angle. And this theorem is not defined. Can I use HL theorem here? That's mean this is an hypotenuse because it's opposite to the opposite angle. So here I have a hypotenuse and I have here an leg. And we say that we must have three conditions to say that these two right triangles are congruent. The first one, if we have a right angle, yes, it's found. If we have two legs are corresponding, are congruent, yes. And if the hypotenuse, and we say that the hypotenuse is a side that's opposite to the right angle, is also congruent, yes. So I will use in the second one HL theorem. Now look at number 5. In number 5 here, we have sides and angles only. So, do you have any information? No. So I will say now for number 5, there's no, it's not enough information. Look at number 6 now. In number 6 here, we have sides that's corresponding with another side, side, and this side is are congruent according to the reflexive property. So I will use S. Now for the last one, number 7 here. In number 7 here, we have angle, side, and look at these two angles. If these two angles are vertical, are equal? Yes, so they are equal, so we can say they are congruent. So I have here now angle, side, angle, and the side is included between them, so I will use A as A, because here we have two angles and the side S is included between them. Now, in the triangle UVW, if the triangle UVW is congruent with EFC, what is the measure of the angle FEC? For these questions here, the first step, I want you to write the letters in the same order. I mean U, V, W, and E, F, C. That's mean angle U is congruent with an angle E. So this is mean that angle U is congruent with an angle E, and angle V is congruent with an angle F, and angle W is congruent with an angle C. So that's me. Let's go back now to my figures. W, where's W? It's equal to C. So this one, it will be 82. And V with F, it's unknown. U with, where's U? With E. So here it is 51. What is the measure of FEC? FEC. Where's FEC? The measurement of angle FEC, sorry. That's mean he asked me about angle E. What is the measurement of angle E? It is 51. Because of what? Because of the triangles are congruent. And we said before, if the triangles are congruent, so all the corresponding elements or the corresponding angles or the corresponding sides in them are congruent. So that's mean the angle V is congruent with an angle E, which equal 51. Now, if I ask you now about angle F as an example, what is the measurement of angle F? You will say now, if you look at this triangle, okay, if you have 82 and 51, and I ask you about angle F, we said that if you want to find the measurement of the third angle, we will use the third angle theorem. In the third angle theorem, that we say the summation of the three angles is 180. So 180 is angle F plus 82 plus 51. Then 82 plus 51 is 133 plus angle F is equal 180. Now let's continue here, please. So 180 is equal to angle F plus 133. It's like an algebraic equation. The angle F is added to 133. So the the opposite of addition is subtracting. I will subtract the same number from the both terms. So the measurement of angle F will be 180 minus 133, which is 47. So the measurement of angle F now is 47 degrees. Now, look at this question here. In this one here, as you see, it's a proof. Given that angle A is congruent with an angle D, O is a midpoint of AD, prove that a triangle AOB is congruent with DOC. So now in the quiz, I will ask you about the proof of two columns. So you have to say that here we have a statement. Oh, sorry. Let's write it as like this. Here we have a statement. That's why we called it two columns. A column for the statement and the second one for the reason. So the first one here, the first one, we say that angle A is congruent with an angle D. It is given. It says in the question. So angle A is congruent with angle D. O is a midpoint of AD. Since O is, if I have this line, and I told you point O is a midpoint of this line, what does it mean? That means this point, it cuts the line into, or it cuts the segment into two equal sides. So that means it makes AO equal to DO. So I will say now AO, line segment AO is congruent with DO. Why? Because O is a midpoint that cut the AD into two equal sides. So I have now two sides, and I asked you, I told you so before, if you have two sides, you need to look about the third side or the third angle. So here we have, here we have an angle and we have a side. Since we have angle and sides, I will look at the third one. Look at angle O here. In angle O, can I say that an angle AOB is congruent with an angle COD? AOB, this angle, is congruent with this angle? Yes, because of the vertical, or because they are vertical angles. So look now back to my triangle here. In this triangle here, what did you have? You have angle, side, angle, and the side is included between these two angles. So I will say now, so because of that now, I will say that that triangle AOB is congruent with the triangle DOC by ASA. That's mean I have two angles with an included side. Thank you.